In this episode of the full Python series, we'll be covering values and types so you can better understand what Python is working with and how it classifies data. So by the end, I should be able to explain what a value is, explain what a type is, also recognize core built-in types such as the integer, float, string, boolean, and NoneTypes. I should be able to use types to inspect values and understand how Python chooses type for a literal. So what is a value? Value is a piece of data Python can work with, right? So examples of values are numbers, text, and logical values like true and false, which are often referred to as booleans. So just as a few examples of values, we have these ones written here. So 42 is a value, 3.14, hello in itself, true, and then the false and none. So a value by itself is already a simple expression as we'd already looked at earlier, right? So let us start off by using some of the values that we've already written here, right? So we've said edge equals 25, right? These are variables and we've assigned them values essentially, right? And if we go ahead and print all of this, so if we go ahead and say print edge and print price, right? Print greeting, and print is active, right? And oops, there we go. Print nothing as well, right? Um, okay, so this last one is not needed. Looks like we have an error here somewhere. This one was not closed. Let's go ahead and try to close it. Okay, so all right, we'll make some changes here. So if we run this, I would expect that this should be printed onto our console, right? So this means that Python essentially did save this to memory, and we're able to print them by calling them. So I just put a quick note here, right? So not that we mentioned that all the above were values, right? And these here on the left are variable names, right? So these are the variable names that are then assigned these values right here, right? So what is a type? A type essentially describes what kind of a value you have and what you can do with it, right? That is why it's important to pay attention to the types, because certain calculations cannot or computations cannot be done on certain values. And to kind of do a deep dive on the types of values, we have these examples here, right? And we're going to be printing them onto our console to kind of let Python do the deciding for us in regards to what kind of values we're dealing with here, right? So when we do run this, notice that on our console we're having the first one, this is the 42, being returned as an integer, right? The second one, 3.14, because it has decimals in it, is being returned as a float. And then the hello, because it has this double quotes, is being returned as a string. And then this one, because it says true, it's being returned as a boolean, right? So if we had true, awesome. If we had false here, it will be returned as a boolean. And then for none, it's being returned as a NoneType, right? I'll go on to explain this later, but none just essentially means there is nothing in there, right? It doesn't necessarily mean it's zero. It just means no value whatsoever, right? So types tell Python how to store the value and what operations are allowed, right? So for example, you can add two numbers, but you can't directly add a number and a string, although you can concatenate two strings, as we looked at in the last episode. So looking at core built-in types for beginners, we're going to focus on these core types for now, right? So we already mentioned the integers represented by int, the floating point numbers represented by float, the strings represented by str, and then booleans represented by bool, and then the special none value, which is of none type. So let us start with integers, right? I know we've looked at this in some of the past episodes, but we keep on repeating most of this so that you can practice, and that way you don't forget what you've already learned, but also do a deeper dive into them. So integers represent whole numbers, right? They could be positive, negative, or zero, right? So for example, all these here are essentially integers, right? So we have x equals 10, y equals -3, and z equals 0, right? So if we were to print type x, would expect it to print class int, as we've already looked at earlier, right? We'll just go ahead and run this just so, again, we can reiterate what we're talking about. We'll actually print all of them here, so we'll just go ahead and also um, print type y, right? And we'll also print type z, right? All right. So I'll go ahead and run this, and notice that here on the console, it's printing all of them are of class integer, right? Okay, now, so as we've mentioned, a couple of integers that you can immediately think of are things to do with counting, right? Indices, sizes, or years, right? If you're doing any calculations including any of this, then you would expect to be using the type integer. The next one is the floating numbers, right? A float. So these are numbers with a decimal point, right? So pi is 3.14159, so that in itself is a float. A temperature could be -2.5, that's a float. A score could be 0.75 or 0.6, that's still a float, right? And if we're to print the types of these ones as well, we would expect to get the type printed as a class float, right? We're not going to go ahead and print all of them because we know they would return the same value. All right. So typical use cases for these ones include measurements, prices, probabilities, or averages, right? So in Python, there is a decimal point, right? And whenever you see the decimal point, just know it's float. Even if that decimal point is essentially a zero, so like a number 2.0 would still be a float, right? So here we have 5.0. If we were to run this to print the type of this value, would also expect it to still be a float. Let us look at strings, right? So we did cover this in the previous episode as well, but let us recap, right? So assuming we have these two strings here, right? We have um, a variable name assigned a value of Alice, and a variable language assigned a value of Python. So if we're to essentially run both of these and let Python compute the values, the types, would see that it returns the class as string, right? So these are the string type. All right. So strings often represent text, right? So whenever you're working with text, just know you're working with strings as well. And then the other ones that we looked at are the booleans, right? Or type bool, right? So these only have two values in them. It can either be true or false, right? And we often capitalize the first letter in this, right? So try to do that as much as you can because it's part of Python's conversion of use. So a simple again, variable that you could write would be, for example, checking the weather, right? So checking whether it's sunny or it's not sunny, right? So if you could say if it is sunny, then true. If it's raining, then false, right? So then you can know when it is raining or when it is not. And if we do look at the type as well, we see that on the console, it is printed as class boolean, right? Okay, so booleans come from comparisons and conditions, which you'll use for if statements and logic as you write code later on. The last one that we looked at was none, right? And we said that none is a special value, meaning nothing or no result whatsoever, right? And it's very common to mistake this for zero, right? Or false, but no, it often in most cases just means that it's an empty, right? It's an empty list, for example, if you use it in lists. All right, so when we run this, we do see here that the type is essentially none, right? So class NoneType. All right, so let us look at literals and how Python decides the type, right? So a literal is a fixed value written directly in your code, right? Python decides its type by how you write it. So when you write this here, this is 10, -3 as 0. Python automatically flags this or detects it as an integer, right? If you write it this way, Python again is going to realize this is a float, right? If you write it this way with double quotes, then or single quotes, Python will immediately tell that you're working with strings. Again, it allows it to know um, which essentially which methods or calculations are acceptable. And if you write, if it does see a true or false, it will know immediately that you're working with booleans. And if it sees none, it means there is, it's a non-literal, meaning that there is essentially nothing, right? So not zero, but nothing. Um, all right, so revisiting the above, 10 is classified as int, 3.0 as a float. 10, even though it looks like a number, but since it has double quotes around it, then it's going to be classified as string. This is a boolean, and this is class type none. All right. So yeah, just put this as a reminder, right? Whenever you see double quotes, just immediately flag something as an integer. As a string. If there is no quotes whatsoever, then it's an integer, and you can do calculations on it. All right. So why do types matter, right? We're going to look at combining values, right? So types control which operations are allowed, as we'd already mentioned before, right? And we're going to start off with this example using two different types just to see how typical calculations will be made within a Python, right? So we started off with A, which is variable A assigned a value of 10, right, which is an integer, and then variable B assigned a value of 3.5, which is essentially a float, right? And we're asking Python to print A plus B, right? And also to print the type, right? Because we have a float and an integer being combined, the result would expect it to be a float, right? So floats are always given a precedence because Python realizes it's important for you to use decimal points, so it's going to make sure that the answer as well has decimal points, okay? And as we can see here, printed on the console, we have 13.5, and then type is float because we had requested a Python to print the type for us as well. Okay, let us look at string concatenation, right? So this one always just works with strings, right? Remember we mentioned in earlier episodes that when you are, you can add essentially two strings by using the plus signs, right? If you want to multiply the string, whatever it is written, you could use the times sign or the star sign. So here we have the name being Alice, right? We can tell it's a string because it's using double quotes. And then we have age, which is 25. This we know is an integer because there's no double quotes, right? So it's a value as an integer. And here we want to print the name and the age, right? We have two examples here, and I'm going to show you. One is going to throw a bug and one should run fine, and I'm going to explain why exactly in just a second, right? So if we have this one, if we try to run this one, notice that immediately we get a type error right here, right? So Python is saying this is a type error, can only concatenate strings, not integers to strings, right? So this essentially means we have to make sure that both of these are of the same type for us to run this, right? So we can essentially correct this by then changing this line of code to this one here, and we'll be telling Python, okay, then print name, right? The variable name is string, plus is we're adding another string to be concatenated, right? As we're writing a word. And then plus, since this is a number, we're going to make it a string first. So make this a string age, right? So then it becomes name plus is plus the age, right? So when we run this one, we do note that on our console we have Alice is 25, right? So that is the beauty in being able to change essentially types. All right, I'll put an R here. You can directly add a string and a number. You can either convert the number to a string or use the formatting methods later, right? So let's look at booleans used with numbers, right? So just for a quick brief, typically in Python, true is often equated to 1 and false is often equated to 0, right? those are binary numbers, right? Makes it easier for computation. So now we're gonna just try to, since we've assumed that true has a value of 1 and false has a value of 0, let's try an expression where we have a true plus um, an integer, right? We do see that true plus 1 is printed as 2, and then false plus 1 is printed as 1, right? Let's even just remove this added values here. If we print this individually, we see it being printed as just true or false, right? So meaning that true always has a value of 1 and false always has a value of 0, right? All right. Let's do a couple more examples on converting between types, right? So to convert to strings, we use the str for whatever we're converting, right? So we're going to look at this code right here. And again, if I'm moving too fast, you can always feel free to pause and work out on the examples on your end as well. So here we have variable x, which has a value of 10, right? And then we have variable text, which we are converting to become. So we're converting this integer variable into a string, right? So we'd call say variable text is equal to string of this value here, right? So convert this value to a string is essentially what we're saying by this line, by writing this line of code. And then we're going to go ahead and make a function call to print text. And then we're also going to print the type of the text, right? When we run this, we do get 10 written here, right? And then we're saying that the class is string, right? Because it's being converted into 1 from an integer. All right, let's look at converting to integers, right? So assuming we have a num string here, our variable num string is essentially of type, yeah, we do have this as of type string, and then we want to convert this to an integer. So what we'll do is we'll create a new variable, and we would put integer in front of it before we open the brackets and call this variable here, right? Variable num string. And then we'll go ahead and print num, our new variable, and then we'll also go ahead and print the type of our new variable num, right? When we print this, we do see a value of 42, and it's telling us the class is an integer, right? But remember, we started with it as a string, right? So this here, this method here essentially helps us to convert essentially the type. All right, let us look at here. I put a note of this will fail, and I'm going to show you why, right? So we said we can convert strings into integers, but not necessarily all strings can be converted to integers. And we're going to use this as an example, right? So we have this one here, it's a string, right? And we're saying, okay, make this an integer, and then we're going to actually let us write a longer piece of code here. Let us say we have a variable. Let us just call it our string. Okay, actually, let us just call it d, right? So d equals hello, right? For example. And then we're going to say, let's make it a string first, right? All right. And then we're going to say print. Actually, yeah, I'll just write a print on this one. So I'm saying print, can use lowercase on this one. So print as an integer that hello, in this case, we'll just write it as d, right? Okay, so when we run this one, notice that it's saying value error, invalid literal for int with best 10 hello, right? So it's telling us that you cannot convert this into an integer, right? So you may ask why, because these are just letters, right? We all know that you can't just typically assign letters a value unless you're counting them alphabetically or have assigned them values already, right? So let us look at converting types to float. we have an example here as well. We're going to run this one and I'll walk you through it in a couple seconds. So here we're saying we have num string, which is this variable has a value of pi, which is 3.14, but this value is offered as a string, right? But we want to be able to do calculations with it. So we're going to essentially first turn it to a float. So we're going to create a new variable here called num. And now we're saying num equals float of this variable here, num string, right? And then we go ahead, we're going ahead to print num, our new variable, and we're going to print the type of num as well. When we run this on our console here in our terminal, we do see two values being printed. The first one is 3.14, that is the now the float that we have, and we're being told the class is float as well, right? Um, all right, let's go to conversion from numbers to booleans then. Um, so if we have these booleans, I know earlier on we talked about values like 0 and 1, but other numbers as well essentially can be assigned a boolean, right? So typically false will stand for any number that is equated to 0, whereas any other number that is not 0, sometimes it's just referenced as being true, right? And there's examples to show it, right? Here we have bool 0, it gives us false, bool 1 gives us true, bool 10 gives us true, and boolean -3 gives us true. And we can confirm that by printing this. We do see on our console false for the first one, and then true for the rest of them, right? Um, so again, this is great whenever you have to categorize some data that you have and you want to figure out which values are 0 and the ones that are not 0, right? Again, great for if else conditions later on, as we'll see. If you want certain actions to be done, if a value is 0, else do other conditions or vice versa. All right, so as a note, in Python, 0 is considered falsy and non-zero numbers are truthy, right? So this is important. Uh, in conditional programming. All right, let us look at the type function in practice, right? It is often important or encouraged that you essentially use the type function a whole lot whenever you're learning because this gets you used to Python types, but later on you can always drop this, right? Because you already know what you're working with. Okay, so again, just to go back and go through most of what we've already learned since the start of the episode. If we have a variable a with a value 10, this already we know is an integer, right? So on printing this, we'd expect it to return int. For b, we have 3.0. This is a float. It has a decimal. This is a string because it has double quotes. And this is a boolean because it's using the true or false, right? And if we run this, this is exactly what we are having printed on the console, right? Okay, let's look at another example here. And this one is working with expressions. We're doing these examples just so again you can get familiarized and be able to use this whenever you're writing your own code, okay? So here we have a variable x assigned a value of 5, variable y assigned a value of 2.0, 2.0 being a float. And here are the expressions that we're working with. We are the first expression, so variable result 1 is the sum of x and y, and then variable result 2 is the is essentially gotten by dividing x by 2, and then result 3 is gotten by essentially writing the string age and then adding the string x right here, this variable here. The results we would expect for this one when we print result 1 and then its type, print result 2 its type, and print result 3 its type. For result 1 would expect it to be a float, result 2 would expect it to be a float, for 3 would expect it to be a string because we're using strings, right? And when we run this, this is what we're getting, right? So we're getting 7.0, which is the sum of these two. 5 plus 2.0, it's making it a float again because it realizes you're using a float number in there. Division always ends up being a float unless you use the double quotes here, where you essentially specifying that you want it to to be an integer instead of a float, right? So great distinction here, and great that you familiarize yourself with that. All right. Okay, so we're going to be taking a moment to look at common mistakes about values and types, right? One is often confusing string digits and numeric values, right? Um, okay, so let us look at this example here, and it's a really great example to be working with, and I'm going to show you exactly why. We do see that our variable a has a value of 2, but notice that this 2 is in double quotes, right? So what does that immediately tell us? It tells us this is not an integer, it's a string. So we can't just add it as if it was a string, right? And if we were to go ahead and say print a plus b, notice that it would give us, it would work on this as if it was a string. And so instead of saying 2 plus 3, it's going to actually just get this 3 and add it to the end. And so it's going to print 23. And if we run this, notice that that is exactly what it is doing, right? So if you wanted to actually work with this as if it were an integer, you would have to first clarify and say print as an integer a plus b, right? Now, if we go ahead and actually run this, notice, okay, print as an integer a plus b. Okay, that yeah. So we had to convert both of them. So print as an integer a, and then plus integer b, right? If we run this, we do get 5. Notice on the console here, right? So the first one is calculated as if it, or computed as if it was just a string, so concatenation, whereas this one, since it's an integer, it uses actual addition calculations, right? Okay, so yeah, we've already done this one here, right? So what we did was first we made a an integer and then b an integer, and then we did get to add this to essentially get the sum of this. All right, the other common mistake is forgetting to convert types, right? And we're going to look at this one here as well. So for this one, we're saying edge is 25, right? The first line of code here would expect it to throw an error, and we're going to run this just to see what we're talking about. So here, when we run the first line of code, which is saying print edge plus this value here of edge, right? On the console, would have expected it to print edge as a string and then the value, right? But it's not going to do that because this is an integer, right? And we can see when we run it, it says this is a type error, can only concatenate strings, not integers. And we had looked at this earlier, right? So what we'd essentially do is we would go ahead and write this line of code that says print the string int plus the string edge, right? So by adding string here, we're converting this value here of 25 to a string. And when we run this, we'd expect that to be written onto our console, right? Edge as 25, right? Okay. The other common mistake, we'd already discussed this earlier, is essentially thinking that none is essentially equal to 0, right? It is not. It is not 0. It is not false, right? It's also not an empty string. It's just a separate idea of there is essentially no value whatsoever. All right, let's have a mini practice session here. And again, just to go through what we've already covered. When we have these variables here already defined, we asked what type each of these variables are. 10 would be a string, 3.14 would be a float. This would be um, sorry, this is an integer, this would be a float, this would be a string because it has double quotes. This is a bool, and this none would essentially be NoneType. Okay, and then predicting results and types. We're working with these ones here, similar to the previous example we did, since this one has essentially a float in it. Addition would expect it to be a float. Division would expect it to be a float as well. And then this one result being converting x plus integer y to a string, that would expect it to be a string, right? Because we're converting everything to a string, right? We'll just run this here so you can just kind of walk through the logic. Easier to build up that as a beginner. So, all right. If we run this, okay, we did not print anything, so nothing is being printed. Again, one of the common errors, but with practice, you immediately know why something is not working, and you can go ahead and actually just execute whatever is needed of you, right? So for now, we're printing these three, right? So arrow1, arrow3, and arrow2, right? When we run this, we do see that the addition again became a float. The division became a float as well, 2.5, and then the string, this one where we concatenated two strings, was result being 7, right? All right. Now we're going to work with some broken code to try and correct it, right? And figure out why it was not running as expected, right? The first piece of code we're working with is this one here. Okay. And so for this one, we have edge, variable edge, assigned a value of 30. And we're trying to print a message to the console, right? And we essentially have that message. We want to have it saying edge plus essentially the variable of edge, right? So when we run this, notice that we're getting a type error here, and it's saying you can only concatenate a string to a string, not to an integer, right? So again, to essentially debug this one, we'll just have to convert this into a string first, and then we were able to concatenate this string to that string, making it whoops, did we print? No, we did not print. So we'll go ahead and say print our message to the console. And when we go ahead and print that, it should be able to write that edge is 30, right? And would expect the same for this one as well, right? This is as a number string, it is 3.5, right? But we cannot calculate this one, right? We'll just copy this so we have clean code to work with. Let's just put it here, away from the distractions. All right, so we have, as a number string, we have 3.5, right? And then in this first commented out line of code, the reason it would have failed is, again, because we're trying to add a float to a string, right? No, actually a string, yeah. We're trying to add an integer to a string. This doesn't work because they're of different types. To fix that, you would essentially have to turn this in the string here to a float first, right? That's if you wanted it as a float, or you'd have to turn it to an integer if you wanted it as an integer, right? So I'll just make this a float, right? When you write it that way, notice that again we did not print, so we'll just have to print that. So print total. So when we do it that way, notice that we get our value as a float, right? Because we specified, converted it first into a float. If we did convert it to an integer, it would just print it as a whole number, and that's an integer. Actually, here we're having a value error, invalid literal for int with base 10 at 3.5. Okay, so we'll just leave it being okay. Let me just do that. Okay, still returning the same error. All right, for now we'll just leave it as a float. But later on, again, we can always convert that float into an integer if we wanted to. So let's just keep this one this way, right? All right, that will be all for this episode. If you have any questions, again, feel free to share them in the comments. Also, just be sure to watch the next videos or episodes in the playlist so that you can be able to advance in your Python skills. We'll see you in the next episode.